Lesson 11.1, Graphing Square Root Functions. This is the first lesson of Unit 11, which is radicals and geometry connections. So we're going to start bridging what we do in algebra, which is almost all letters, variables, constants, multiplying, dividing, and geometry, which is largely shapes, pictures of shapes, angles, things like that. So we'll start with what's a radical expression. Well, obviously a radical expression has a radical in it. And an example would be something like that. Y equals 2, radical quantity of x plus 3 minus 4. The general form looks just like that, but we put variables in. So we'd have an a constant out front. X is our variable, plus h constant, plus a k constant. Why do we use those letters? I don't know. It's tradition. So what does y equals square root of x look like? Well, we can do this and start going like that. But you've done that often enough. I don't feel like doing it. The only reason I'll do this is to show you that I can't take square root of -4. Square root of 0 is 0. Square root of 4 is 2. So you can go ahead and plot it. But I'm not going to do that. I'm just going to show you what it looks like. Looks like a swoosh up to the right. Notice that it stops at 0, 0 because, again, can't take square root of a negative. The smart move would be to just go into a calculator and graph it. You'll see the same thing. Swoosh goes up to the right. So, just like last unit when we started graphing quadratics, we want to know what happens to the radical when we do things to it. So we want to put in our parent function, and that was our parent function that we just did. It's our parent function, y equals radical x. And now what happens when we put these in? Let's go find out. So down one, let's put 2 radical x. And let's put 0.5 radical x. Now the problem is we can't really tell which is which, so we got to give them slightly different looks. We'll make that one a big, thicker line, and this one we have to hit a few times till we get down to the dotted one. There it should do. Great. And graph. So notice the big thick line is 2 to the x, 2 radical x, and the line below it is 1/2. Looks like our dotted line didn't show up. Wonder if I forgot to hit enter. Or maybe it just looks like that. Yeah. Doesn't show up as a dotted line. It just kind of looks like that. So let's do this. Let's make this one green. It's up higher. It is vertically expanded. And let's make this one purple. It's vertically compressed. Just memorize them. You have your calculator handy, so you can always check, but it takes a bit of time, so if you can memorize them, that's probably better. So what's the graph of y equals -root x look like? This one you should know, because it's the same thing as last time. What happened when we had our quadratic and we put a negative out front? That's y equals radical x, the parent function. Put this one in green again. Just reflects down underneath. Don't know how we want to describe these. I will continue to go with the words fatter and thinner. We got fatter compared to the parent function. got thinner compared to the parent function. If you have a better way, want to say it's closer to the x-axis, it's further, that's fine with me. So 2 more. You should also know this one. What do we do if there's a +2 hanging out here? Again, here's our parent function. Let's go with green again. Well, last time, if we had a +2 hanging out at the end, it just moved everything up 2. So number out there moves it either up or down sometimes by the number, in this case by 2. So pretty straightforward. You can always check these with your calculator. Not too bad. Flipping over. Now the challenging one. Challenging because we haven't done it before, and challenging because it is counterintuitive. Parent function. And now, what do you think happens with the -4 on the inside? Well, the +2 moved it up or down. That's on the outside. The -4 is going to move it left and right. So minus, oh, it must move to the right. That's the problem. It actually goes the other way. So it either moves right if it's a negative, or left if it's a positive. Very upsetting to many, many students of mine who really don't understand why it does that. I could just say it does, or I could point to the fact that if you look at a graph of y equals x, which would be your parent function, and then you add in a 2 or something, we're used to saying it goes up and down the y-axis. But if you're comparing it to the x-axis, it also moves left. That's the only way I really have to describe it. Moves left. Bottom line, memorize it, or, as I was about to show you, be prepared to graph it if you can't remember. X minus 4. Enter. There's the parent function. And there it is. I put a -4 in, and it goes to the right. So now let's put it all together. You can do this in any order you want. I use dotted lines. Here's my parent function. Notice I always label the heck out of everything. And now let's do the negative. And let's do all this in green. So that's going to reflect it down. And the reason I'm dotting it in is I'm not done. Let's do the -1. You could have done any order you want. Let's do the +4. It's my third step. +4, I want it to go right, but nope. Then I remember it goes the other way. And finally, the 2. The 2 goes further away, so when I reflect it down, whoops, my bad here, would be here. 2 would make it fatter. It's a lot. When you put it all together, it's a lot. The steps up to it are not bad. You put it all together, it's a lot. You can always check. See how you did? Here's my parent function. There it is, right where we said it would be. 1, 2, 3, 4 over, 1 down, flipped, and a little bit fatter. You can see that's flat, and that's a little bit of a fatter curve. That's it. Get practicing. Good luck.